Previously on The Bald Engineer.
Oh God, wait a minute, what? Ooh, you're dirty. Oh no. James, you're looking at the wrong chip. Oh my God. Excuse me. Farts. And F stands for fun. Pick. Yep, fell right for that one. Tab is grabbed. Oh no, 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 no. New work. Oh my God, are you kidding me? And why is it triggering now? That could have gone a little better. Hello everybody, welcome to the stream. How's it going? All right, let's check a few things. That looks good, that looks good. Bellum, welcome, good to see you. All right, let's get this stuff. What is going on? What did I just do? There we go. That's what I was looking for. Okay, all right, so originally, I was thinking about doing something around KiCad 8, but I think I'm going to wait on that because I want to spend a little bit more time with it before I do a stream on it. I just had a thought just now. I should wait till the first release candidate comes out because then at least we know it's feature frozen. That said, here's what we're going to do today. I want to redraw, where's it at? The schematic for the power supply in the Apple IIe. There was a post on Vintage Computing Reddit where somebody's having trouble with their power supply, and I realized there's not a lot of references for the Apple II power supplies. Now the problem is I only found one reference, and or only one schematic, and I know there are multiple designs. So I thought, okay, we'll redraw this one because most of the core components are probably going to be about the same. And then I'll just keep looking for other references, or worst case, I think I've got an Aztec. Well, let me rephrase. I think I have two different designs, at least for the 2E. For the Apple II Plus, I have two Apple II Pluses, but they both have the same supply. And then the 2GS, I actually know I've got multiple. I've got so many of those supplies. So, did KiCad change the library formats again? I don't think so, actually. This update is a lot of stuff was done for Schematic, and so a lot of the it's not. I don't think it's as bad of an update. I do know that the file format has a slight change because, or maybe it doesn't. It's just that in general you can't open the nightly file in the current build because the current build will always say, "Wait a minute, this was made with a newer version." So I don't know, whatever that means. Look at that, like a glove. All right, that's pretty seamless. Oh, come on, really? So what's going on here? I'm sorry, I totally forgot. I jumped ahead. So what I found is in the Sam's Computer Facts, which is a technical service manual, a third-party service manual, they have one schematic for the power supply, but they don't identify which power supply it is. I was actually going to look a little bit closer and see. I'm of the mindset there's more than one power supply model because I believe Apple used at least two vendors to manufacture them. What I don't know is if they were, what we could do? I know we could go look at is, I know who would know. Reactive Micro would know. Why didn't I think of this sooner? Reactive Micro. Whoa, I must have been I must have been capturing a screenshot or something. That was like zoomed. That was zoomed so much I think I could see it yesterday. Okay, so Apple II series. Nope. Apple II. What I'm hoping that Henry has is a cap kit. What I do know is he sells these replacement power supplies, which I actually have one for I have one for my 2GS, and it's a really nice kit. Highly recommend. But what I was hoping he would say is I was hoping he'd have like a recap kit, and I don't see anything like that. No. Okay. Maybe there's only one vendor. I don't know. Quantum Zoom. Yeah. Yeah, because he just does it by model. Huh. I gotta tell him his images aren't aspect ratioed correctly. I wonder if I bought one of these. I wanted one of these. Anyway, okay. All right. So anyway, we got this power supply. We're going to redraw this schematic. So let's get going. So what I want to do now is let me save this as I'm going to put it in. What I don't want to do is here's where I'm going to put it for now. I'm going to put it in a directory and then ignore it. 2E power supply. Ooh, that didn't work. Reference. So has everybody had a good holiday season? I know this is so this will be the last time I see or talk to any of you in the year 2023. I mean, just because it's the end of the year. I guess if you ping me on Discord, then that's not true. So whatever. Let's do this, and then I'll put stitched schematic. I might actually end up putting this like on baldengineer.com or something, just because I stitched it together, and so I actually made it readable. Or maybe I wonder if I could just upload it to archive.org. Hello, Robert, or is it Robert? Welcome to the stream. Always good to have a lot of time off of work. Really? What's that like? You know, actually, I really miss that. I remember when I had a corporate job. Basically the 2 weeks of Christmas and New Year's, pretty much everybody would take off that I worked with. I would generally take that time off, and it would be like a great time to decompress. And it was enough time that usually by the time like now, so come Monday, well, not Monday, but Tuesday, I would actually be ready to start working again. I mean, of course I didn't want to, but it's like, at least I'd be ready for it. So, okay, so let's do a couple of housekeeping things, and then we're going to get moving, because we also need to make a, let's go revision 1, Apple IIe power supply. And then I want to do ball.ee/bit preserve, and then reference, how's this look? I should have done this ahead of time. I totally forgot. Sam's computer fax. Sam's computer fax. Apple IIe AS2064. This is one of those things that kind of amazes me about Apple, is that they pretty much stuck to the same model numbering system all these years. Been off like a month. Yeah, actually, my first time out of college, I started working in 2001, and like I started, and I think it was for the first 3 years I worked for the company, I was at a 10% pay reduction, because it was right as the .com bubble burst and the economy took a sharp hit, all that kind of stuff. And so we did, like, my first 2 years, we did 1, if not 2 weeks of forced time off. And it's because so many of the old timers had like a month and a half of unused vacation, and so it was a way to force them to take their time off. And I remember my manager got really upset with me, because I was like, well, I'm taking it as unpaid time. And he said, well, no, that's not the way this is supposed to work. You're supposed to take your vacation time during these forced times off. Like, one of them was like the first week of July. I was like, no, that doesn't work for me, because I only had 2 weeks to begin with, and I wanted to take it off at the end of the year around Christmas time. Also, if I got hurt or sick or something, I wanted to use the time, like I'd want to use the time for that. And if that happened, say in August or September, and maybe financially I wasn't in a case where I could take that time unpaid, I was like, I can take it unpaid now. And it was just funny, because like nobody thought about the new people they had hired that year, that we all got screwed. Like, we all got 2 weeks of unpaid time, because or we couldn't take any time off, and that was just annoying. Well, the video will be live at the end. It'll be unlisted. So if you had the link to get here, then you'll be able to find it. But yeah, I don't publish the live streams to my feed. The problem is there's too many spots like this where I'm talking about nothing, and I don't have the patience to edit all that out. Although, I guess I could just download the video and edit the original file, because that'd be a lot faster. Anyway, yeah. I gotta think about that. It's funny, you go from Twitch, which makes it really easy to archive your live streams, but impossible to find them, to YouTube, which makes them really easy to find, but impossible to archive the way you want. Like, I don't want live streams to get published to the normal video feed, but I want them to be on the live tab. But you can't, there's no way to do that without, you can't get both of those things. Anyway. Okay. Let's go create a symbol library for the Apple IIe power supply. So we'll do new library for this project, and we will call it the Apple IIe power supply unknown library. The reason I'm saying unknown is because I don't know what design this power supply is. So at some point I'll go back and change all the references, but for now we'll just leave it as a unknown. Oh yeah, that's right. There's a live playlist. Thank you, Bellum. They do show up in the live playlist because I do at least do it that way. So there. I'm a YouTuber. All right. I've done all of that so that we can finally get started. Live, not live, projects, bitstream, bit preserve, Apple IIe, Apple IIe power supply unknown, reference, and then I want this image. What we may not get to tonight is we may not get the transformer done because that is going to be kind of a pain, but we'll see if we can get most of the other stuff taken care of. And then I want something like that. And so let's see. So what I would like to, the way we're going to start this off is we're going to put a 1, 2, 3. Oh, let's, whoa, what'd you do that for? I want to make this small. Bring this over here. Boy, it's been a long time since we did a schematic from scratch together. I almost forgot how to do this. It's really not that much different. The biggest difference is the size of the passives, because it switches relatively slow. But it's, you know, it's a typical flyback. So you go in and or a pulse DC, I mean. So you got a couple of transformers, the switch controller, which I don't actually know where it's at. I guess, actually I don't know what they're using for the switch controller. I don't think that's what this was, but it could be. I didn't really look at this very close. So, but if you look for the Sam's Computer Facts Apple IIe, that's the schematic that I'm following. What I do think they did is in this redrawing, this stuff is actually off board. So we're only redrawing what's in the dotted line. Everything else here is like, it's almost like they're just saying we wanted to reference that it's over here. Yeah, I think what I find interesting about the Apple II computers having a switch mode power supply is that in the late 1970s and early 1980s, that was not a super common thing for a home computer to have. Most of them were more or less a linear design. And so I just find it interesting that even with the original Apple II, they already went towards a okay. I'm actually not, not sure how I want to do this yet, because this is, I'll make that invisible, because what I actually want, I wonder if I can find, what do I want? I might have already drawn this symbol, because what I'm getting at right now, what I'm starting with is, so we've got this L and N, so line and neutral, line and neutral. And what they're trying to indicate here is that there's actually a there's a wire that plugs into the board. So the actual power supply PCB is going to start on the right side of this arrow. And what they're trying to indicate here is that this is probably the IEC connector that's on the back of the power supply. And then there's a wire that runs from there and plugs into the PCB. And I think when I drew the schematic for the monitor, the Apple IIc monitor, I think I actually drew that symbol. I did. So what I want to do is I want to copy that, and then I'm going to paste that into this one and save that. Is there anything else in there? Because I want to close this. I just did power supply rails, which will create new ones for this. Maybe the EMI filter. We'll check that out. All right. Okay, so then, cool. So then we've got that now, so that I can come back over here. We can say add, and then it's going to be con off board. I'm going to rotate this way. I guess the direction doesn't really matter. And then we're just going to draw like this, and then this is going to go somewhere over here, and then this is going to come down somewhere over here, and this is going to be, I'm actually going to hide the reference. I'm going to name this L. So let's hide the reference and name this the L. Hey, Silent, how you doing? Good to see you. Happy holidays. All right, and then let's go ahead and add a switch. What am I thinking of? It's just a single pole, single throw switch. And we'll go ahead and add that right here. Oops. Do one of these, do one of these. This will be S1, and it's called power. Imagine that. So move these over here. Move this, be aligned like this. That looks good. All right, that's all easy. Save that. Let's move this down while we can. I'm not going to worry about drawing the P20. I will put a 120 volt AC at 290 milliamps. Wow, that's actually kind of crazy. That's funny, just to think about, because the computer itself on the 5 volt rail, I think draws 500 milliamps, but then because this is a switch mode supply, the current coming in at the higher voltage is going to be much lower than what goes out. So it's just funny to think about that. Then I'm going to draw this. Let's add a ground, and I'll stick with their I want it to do the rake just because that's what they used, even though it really is going to earth. That is an earth ground. Undo that. Okay. Now I wonder what this 1-1 and 1-2 is. Okay, so that's this schematic, and they're trying to illustrate things, so I'm ignoring those. So then we need a fuse. Polarized. We want small polyfuse. This is not a polyfuse. And this is 2.75 amps. I wonder if VDR1 is an actual net name. All right, so this looks like one of our EMI caps, which of course you want after the fuse because you don't want to store energy up at the front of the fuse. Then we'll kind of do one of these, and I'm going to use G and move this down and over a little bit. Move this over. That looks pretty good. So this is going to be C23, 0. So this is probably, I wonder what this is probably 0.01 microfarads, which is probably 10 nano. And then let's add voltage, make this 1 kV, and show that. And see how that works out. All right. So that's got me a little bit. So this is obviously a what do you call it? It's an NTC. It's is it a thermit? It's not. Basically, this is the short circuit. This is the soft start. So this thing gets hot when it shorts out, when there's a short, and so it disconnects the line. But then as it cools back down, current can start to flow again. So, you know, if you have if there's a bunch of inrush current, this thing will limit the inrush current, or it should. Why is it on the neutral side? This one, I'm not sure what the VDR is. That's not familiar to me. I mean, ground planes are always a tricky. There's always a massive amounts of it depends. And so, oh, it's a varistor. Oh, okay. Oh, VDR, voltage dependent resistor. Duh. So that's an MOV. So today we would call that, well, I would call it an MOV, but that's because I worked for a company that made them. And then an NTC that's probably negative thermal coefficient. So it is a thermistor, right? Yeah, because it's a, okay. All right. Now I see what they're doing. Anyway, so the ground plane thing, the problem with answering the question is there's always a lot of it depends. The biggest problem you run into is if there's only one ground plane and it's also used to carry signals, then you can run into issues where sections of the ground plane are at a different potential than anything else. And so it's really difficult to have a ground plane that's broken up by other stuff and keeping everything, keeping all the loops really tight. You know, that's why ideally, like in a four layer board, you would have one or two of the inner layers be pure ground. That way there's always a short coupling distance to a ground plane for all of the components. A mistake that gets made, and I have made this mistake myself, is filling the top and bottom of a 2-layer board with ground and then having signals on both the top and bottom layers. Trying to manage those ground planes is very difficult. It's really important that you use tons of vias to connect them together so that you try to create one continuous plane. Frankly, unless you're in a super cost-constrained application, the better option is to just go to a 4-layer board and use, like I said, use at least one of the internal layers as ground. Also, like I said, though, that there's lots of, it depends. So that's where I've started. That's where I've actually started to go is if if I feel like ground, if I feel like the circuit has a sensitive ground element, or ground is a sensitive the design is sensitive enough, then I'll just go to a 4-layer board and make the middle layer nearest the components. So I'll go signal, ground, power, ground, signal. Yeah, sorry. Signal, ground, power, signal. And then I only put ground planes on the top and bottom if it's directly underneath a specific component, and then I stitch it with, or I do a ton of vias to get it connected to the ground plane. That is not always how I've done PCB design, but that's what I've started to do now. I have been educated in the errors that I was making. I don't know what 5 means, but what we're going to do is we're just going to add fields. So we can match what they were doing. All right, so then this comes into here. This is going to come down to here. And I think for that transformer, we're going to be able to get away with an existing design. Now, keep in mind the boxes that have like the, I can fix actually. I'm going to fix this real quick. I got rid of the logo. Which one am I on, James? Background. There we go. There we go. That's better. Oh yeah, I didn't need to go to studio mode for that. See, I can move things. Okay. Okay, that's better. Let's go up to this point right over here and right over here. Let's see if there is a transformer that we can use. Actually, what is available? Yeah, we're gonna have to make our own for another section. All right, boy, that is huge. Good Lord, that is huge. Really? Is there anything smaller? There's not like a transformer that's small like other symbols. Fine. I'm just going to use it for now. I don't want to deal with this at the moment. Okay, so probably doesn't matter. I like how this doesn't tell us anything about the windings. That's helpful. It's just a transformer. I guess you could say it's more than meets the eye. Oh God, that was so bad. I can't believe I said that out loud. My bad. Moving on. Oh, I'm going to we are going to turn off auto annotation. Because we're copying the annotation from something else. 125, edit, AC visible. Move this over here. All right, and then this is going to come up to here. Then we're going to have another capacitor roughly here. That's what I'm going to do. With a junction. This is going to be C3, and this is going to be a 2.2 nano, and it's rated for 400 volts AC. Interesting. And it goes to the chassis ground. What? Wait a minute. That can't be right. And what's the point of the transformer? Oh, that's not a transformer. Dumb. It's a choke. It is a transformer, but it's actually they're using a transformer, but they're using it as a common mode choke. Duh. Yeah, the numbers in the boxes are for the Sam's guide. So this is a third party made a technical manual, and then somewhere else in this guide they have pictures and measurements at each of these points, so that you can just, if you use a scope or multimeter, you can say, okay, at point 16 or node 16, this is what you should be measuring. And so later in the guide, it references those. I'm not really interested in, I'm not interested in that aspect. So we're just going to ignore that. I do have this like dream. Like one day I want KiCad to support hyperlinks to like media, so that you could actually have a thing that you click on and then show like a scope screenshot. Because like for the Apple IIc, we repaired that monitor a couple of years ago on a live stream, and then one of the streams we did is I went through all of the nodes on the monitor and I took scope screenshots, because I wanted to have that for future reference, but I don't have a good way to document it now. And I never did. Of course, now I don't know that I remember it, but Okay, so is there a bridge that looks like this so that I don't have to think about it? Yeah, I'm not familiar with how AutoCAD does it, but that sounds like what I would be thinking. I was hoping there would be like a bridge that's designed, that's all just laid out in this vertical manner that we could just use. I don't want to. Okay, I think I'm just going to draw one. I highly doubt if I do KB. Oh my goodness, these are actually in here. I guess diode bridges don't change that much, do they? So this comes in, anode, connects. I'm just going to draw it. We're going to draw it from scratch. Okay. I just realized the symbol editor doesn't really have I don't want to redraw the diode symbol, but maybe I can import it from something else. Like what I need to look for in here is diode. I want D small filled. I'm going to come into this one, and then we're going to move everything. All I want is this. And then we're going to go back to this one. I'm going to do a new symbol, and the symbol's name is going to be dB for diode bridge. I'm going to paste, and I'm going to save. And I'm going to close this because I want it to be, do I want to save changes on that? No. There we go. dB. All right. I did all of that because what I'm trying to get towards here, let's move some of this stuff around now. Because our device will actually only have 2 pins, but I wanted the diode symbol. So in fact, I'm going to delete these pins. I'm going to do something like this. Why is that grid not lining up now? What is going on? Is this not on the grid? Yeah, okay. All right, well, that's what I wanted. I don't know what's going on there. Oh, wait a minute. I know what's happening. No, I don't. Hey, where'd you come from? Okay, so part of the problem is this triangle is not the right. Okay, I'm starting to see what they did. So we're going to change our grid to be 0.6035. But we have to be careful because we got to get our pins on the right. Oh my God. It's like it won't paste it back. Okay, fine. You know what? Fine. I'm tired of this. This was supposed to be, let's draw a symbol real quick. And it's turned into whatever this is. I don't understand. Oh my God. I don't understand why it's... Okay, I see it now. Now what's happening? Where did that come from? The problem, I get what the problem is now. This is a really terrible grid to draw this symbol on. But I want to keep it in increments of, basically you want to do 2.54 divided by 2 divided by 2 divided by 2. Because if you go in another increment, then you can have some problems. Like this shouldn't be 0.6035. This should be 0.6035 divided by 2. which isn't 0.01. It's 0.0. What is going on? Okay. Oh. Okay. This is a lot of effort to get something to look the way I want it. Because I don't think I can get away with this. Except I can. That's actually all I wanted this whole time. All right. And then I want it to go over here, but then these get turned around. So that's that way, and then this way, and this way. Oh my goodness. All right, so then I want to draw a line out like this. And this is where the next issue is going to come, is did I get that in a place where this is going to work? Oh. I'm still not done because we still have to come up to, and then this one down here will come to here. All right. So now if I try to, now what I want to do is I want to go back to a 0.1. So if I did this right, I should be able to go back to the 1.27 grid, which is the standard for KiCad. And then I should be able to add a anode pin like right here. Okay. And then I should be able to add a cathode pin right here. And then let's hide the pin name. Okay, we just won't name it. Damn. Damn. All right. Three and 4. So we gotta go back to the other grid now. Let's go back to the user grid. And then we gotta move everything over. Maybe we can just do it this way. So I will use the arrows this time. I'm gonna hit M for move. And I'm going to move everything over this way. Because then I want to go back to 1.27. I don't think this is going to line up. It's probably going to be close enough. Nope. Although what I might be able to do is, can I delete this and then just move this down? Yeah, we're just going to do it that way. Pin length plus 1.27. Yeah, let's delete. Nope. I don't want to do that. I just want this line. Nope. No, 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 no. Oh, it's one polygon. Darn it. Fine. Whatever. I'll just do it this way anyway, even though I didn't want to. It's being a stupid head. Then we'll go back to the really fine grid. Now keep in mind, normally there's a hotkey to switch the grids, but because it breaks so many things in Schematic, I refuse to use it. Use Y and move this upside down. And then just do something like that. And I'm not going to draw a box around it. Cool. So we'll save that. So come into here. We'll go out there, go out there, and go out there. Okay, whatever. So then we can come back over here and we can say add, and I can add my DB. This will become DB1. I'm gonna basically put it right here. Boy, did I make that way smaller than I need it to. Oh, actually, no, I didn't. That does work out because it's gonna go roughly here. Oops, that's gonna be DB1. All right, let's do an update symbol, update close. All right. So this is going to plug into here. This is going to connect between the caps. That's not connected. This is going to go somewhere else. So we'll just do this for the moment. And that's going to go somewhere else. You know, I did all that to draw that bridge, and I don't like it, but I'm not going to change it now. All right, so where does this go down to? It goes down to an electrolytic capacitor. All right, so let's add a C polarized small. I just like the small symbols better. And then I'm going to roughly guess it's going to go somewhere around here. So I'm going to do that. And then there is a jumper that this goes to on what? Yeah, it goes right there. All right, so we need a jumper to bridged. I'm going to do one of these. Come on, come on, come on. Fit, fit, fit. Okay, so I'm going to use G and move this around a little bit. And then we're going to bring this over here and then use W to close the wire. And then on here, we're going to just jumper. I'm actually, you know what I'm going to do? I know what I'm going to do. I'm going to leave that as unannotated, and then I'll just annotate it at the end. And then that way anything that doesn't have an annotation on this will just get a random number. All right, so that connects from here, from that side of the transformer, the choke, through here, goes to this capacitor, which is a little bit farther down here somewhere. And this is going to be C6 and 47U and 250 volts. Which for some reason they put over here. We'll follow along because I'm not sure why. Also, looks like this is upside down, doesn't it? that looks like the positive symbol. That looks like the positive symbol. So this is, which one is line? This is line. And it can go that way. And then neutral comes in. It goes that way. And then when neutral is going the negative direction, it can come down this way. I need to see that symbol somewhere else to convince myself that it is upside down. Upside down from what I'm expecting. It is. Yeah, so that is the positive. Okay. Wow. All right. No, redo that. I believe the dash lines on L2 indicate that it's an inductor with a ferrite core instead of an air core. I might have that wrong, but I believe that's what I think that's what they're trying to say. Without having any other specs on the inductor though, it's kind of a pointless, it's kind of useless. And what I'm guessing, what I'm starting to think is, I think this guide, this third-party guide, they must have just reverse engineered the existing design, because they don't even say like what these coils are. So it's probably a common mode or it's probably a choke. But yeah, maybe it's a toroid. Huh. Well, speaking of inductor, let's see, is there a... It's not a ferrite bead. Why did I click on that? Why was I thinking that? EMI filter. It's not coupled. Yeah, ferrite. Yeah, so I guess it is just a symbol for ferrite. I think it's just to indicate that it's not an air core inductor. But like, we don't know what material they expect it to use or anything like that. So it's kind of like, that's not very useful. All right, and then that's going to go to another one of these capacitors. This is almost an maybe this is actually part of the EMI filter. That kind of looks like a pi. I'm not really giving this any thought. A 150K resistor. All right, so let's go edit the symbol so we can get these all done at once. So it'll be 150K, and then we'll add 1 watt. Well, nope. Over here we'll do 1 watt and show that value. Move both of these up. Move this one down. Let's do a save. I don't know when the last time I hit that button was. All right, and then let's see. So then this wire continues up this way. And then it looks like somewhere around here, we're going to end up at... So here's a question. I wonder what these... Can you see this? I wonder what these X's are for. I wonder if that's meant to indicate that it's not populated, or... I can't. I don't recognize that in a schematic. I might have to post that on a forum somewhere and see what other people think. Because I'm not sure what that would indicate. The other thing we can do, well, I wonder if I have one of these power supplies, because sort of my other trick is I just go and look at one of them and see. Oh, nope. What I wanted to do is 10 nano, this and this. So I'm just going to do this for the moment. I'm just going to literally put an X here and here. And then let's add a note, and I'm going to make it orange. Just so that we know what's going on there. All right, let's get a diode, small, filled. And that's going to be something like this. Let's edit that. So this will be D1, and it will be a RGP10A, whatever that is. Wait a minute. Why does this have simulation stuff? Did I get a PSpice part? Or does this just happen to have PSpice information? I guess it does. Interesting. I haven't done much with simulation in KiCad, and I no disrespect to the people that are working on it, but I just don't. I find it's pretty clunky. It's like if I'm going to do a simulation, I either use iCircuit, which is an offline version of Falstead, or I just use or I go straight for PSpice or LTSpice. But the simulation engine built into KiCad is really just it's built on ngSpice, which there's not anything wrong with that. It's just it's not the easiest thing to work with, and most of the symbols in KiCad don't have PSpice models, so it's I don't know, just clunky. I also feel like, and someday I'm going to do a video on this, is I think people misunderstand what the simulation in KiCad is for. And they kind of think they're going to like draw like this whole circuit and then hit simulate and see how it works. And that's usually not the case for lots of reasons. All right, I think that's as far up there as I want to go. I'm going to put this up here because there's more room. I didn't realize there's stuff down here. Yeah, I mean, it's the can I show something really quick? Because I have a simulation that I was working on, but I mean the problem with with like the KiCad simulation tool, again, I'm not trying to knock it because I think people are working hard on it, but you're basically I can't remember how to do it, but you basically have to give it a PSpice command. Like a PSpice directive before it can do anything, because there's not really like a UI to set stuff up. And even if there was, I don't know. It's just, can it do one? Sure, but first you have to use the models that have spice elements defined. So for the passives, that's like the diode. You have to define the terminals. But then for any of the active devices, you have to go find a model for them. The vast majority of parts in KiCad do not have models, and so that's that's a non-trivial thing to do. And so that's why it's like, if I need to do an actual simulation where I'm trying to see how an actual part works, then I would rather just go into LT Spice and hope that there's a model for the part there. But ultimately, I think the problem is you have to understand that like a PSpice simulation is not meant to be, it's not what most people I think expect a simulator to do. I think people are like literally like a very common one I see in KiCad forums is somebody will want to build an AC to DC converter because they want to simulate what the AC is going to do. And it's like, well, it's pretty irregular to do that kind of, even that kind of schematic. Like you don't really do like an AC source going into a rectifier, then going into a 7805. One of the problems is you need a model for the 7805, and that can vary depending on the parts you're using. But the amount of time it takes to generate the slow AC for the relatively fast DC, I know that sounds weird, but any kind of ripple or anything on there, you're going to wait a really long time to simulate that. Where instead what you would do is you would simulate the AC section, get an idea what its waveform looks like, and then just create that waveform with a source on the DC side, because that will get you the same information. But it's like, that's what I don't think a lot of people that haven't done PSpice before, I don't think they understand that. Like that's, anyway, I don't know, I'm just rambling now. Simulating electronic circuits is not as straightforward as I think some people think it is. Like for example, you can't it's very difficult to simulate, say, a floating input to a microcontroller. Well, shoot, there's another one. I can't tell you how many times people are like, well, I don't have an Arduino. Can I simulate this Arduino circuit? I mean, yeah, there's things like Tinkercad that will let you sort of simulate some things. But like if you want to, say, connect a digital output into an analog filter and then have that filter go into something else, probably not. I mean, that's probably not. Anyway, I don't know. Simulation is a whole science in itself. I'll just stop there. End rant. All right, so I'm traveling back up this line, and then I want to come back over to here because I want to basically get up to this transformer on both the top and bottom. So let's see. C5 is going to be upside down. It's going to go here. And then we're going to move. Let's edit this. I guess all we got to change is this. And then we can move this up here, move this down here. Here's the other way I'll try. I can try to quantify this. I think it's naive to think that the same schematic you use to make the PCB would be the same schematic you would use for the simulation. And it's just because there's certain things you have to do in the simulated schematic that you wouldn't do in a real circuit. For example, if you're trying to look at the output of a regulator, you need to put like a 100 ohm resistor on the output. That may not be in your PCB, but you need that because the simulation needs a closed loop in order to do the pieces together. Hey, unexpected maker. Happy Festivus, and happy Festivus to you as well. Hope things are going okay on your side of the world. So this comes down somewhere over here, and then this comes over here. Let's move these to this side. Make that C24. Then we need another 100K resistor. I'll put this one. Oof. All right. So I'm going to do all that. And then I'm going to move this down to, they want it over on this side. Sure. Sure, if you want it there, you can have it there. Whatever you want. You can have any color you want as long as that color is black. That looks about right. So what was your latest product? Was it the Tiny Watch? Is that what I remember seeing you were playing with? Maybe like before last week. So there is a line that comes from, it's going to come from that transformer. That's going to go all the way down to something down there. Okay. Well, originally I was thinking we're going to have to draw a custom transformer. But I wonder if we have a 1P2S. Does this look right? Transformer. That's actually closer to what I want. No. Okay. So what we're going to do is we're going to make our own. So we'll do edit symbol. Can a Pi 0 2W handle 1080p? Ooh. I don't know. Certainly if you don't need 30 frames a second. Just kidding. Let me change my grid settings back now that we are doing normal things. All right, so I want to do a save as. I want to save this into the 2E. PS. Tiny Watch S3 and Bling. Oh, okay. Wow. I probably saw Bling, but I don't know what that is. So I'll have to go check that out. My bad. But yeah, I totally remember seeing the Tiny Watch. I was like, oh, that's cool. That's something that can go on my list of things I want to play with. All right, we're going to call this 5. We're going to call this 6. And then this one will be 2. We'll edit this one to be 1. We'll make this one 3. I'm not going to put the turns ratio in the symbol. I'm going to put it in the schematic. 4. So we got 5, 6, 2, 1, 3, 4. All right, let's save that. Close that. We're going to delete this one. We'll add what we just made. Transformer PS. There we go. Beautiful. It's like I've done this before. I'm just going to put this over here because I have a feeling we're about to run out of space. So let's hide this and name this one T3. And then let's tie. This is going to go to ground. But then this is supposed to come around this way somehow. And I believe that goes around there. How are we going to do this? All right. Nope, not there yet. Okay. We'll clean that up later. I just wanted to get that line in there. because once it's in here, it'll be easier to manipulate. Okay, so then we're going to add a non-ferrite coil for L3. That's going to connect to 2. So let's hide this and name that. Okay, now what can we do? We're going to see. Let me back up. Let's back up. Let's go put the turns. I think these are turns ratios. I don't know what else the numbers would be. I'm not a coil guy. So we'll say 16.1. Makes me think what they did is they just like took the coil out of the power supply, hooked it up to a function generator, and just see what it output. And we're like, okay, that's close enough. All right, R small. That's what made me think of that. So let's go and do a R6 and 27. And then that can connect up here. And then this is going to connect down here. Oop, missed that connection. I'll get it. I'll get it. Get it. Get it. Ooh, what are you doing? No. Connect that. There we go. There we go. There we go. What I would like to do is move this down. So is anyone here? Does anyone watch For All Mankind? It's on its 4th season. I think episode 8 of this season comes out tomorrow, or maybe it's tonight at midnight. I am super excited. It is season 4. I was about to start disliking, and it has massively picked up. See, that is the symbol for, see, this is like, there is a library for simulation parts, which has all the spice stuff defined. And so I think this might even have a basic model for an NPN. But what I would like is NPN, what am I looking for? Q, NPN, yeah, something like this. But what we're going to do is we're going to edit this, and we're going to make our own for this schematic, because they didn't give us pin numbers on almost any of these, which is very frustrating, which is again making me think that they just they reverse engineered one of the power supplies. Yeah, I like, so let's see. I would say episode 6, it really picks up. 1, 2, and 3 were pretty slow. But I'm liking it better than season 3. And I think it's because most of the cast is new, and so the storylines are just slightly more interesting. Which I think some people didn't like the idea of it because most of the cast is new. But I mean, the timeline is 40 years ahead of where the first season was. So, you got to kind of do something. But overall, I'm enjoying it. There's a couple there. It's interesting because the writing, and it's been this way the entire show, so there's nothing about this season, but the writing has been so mixed. There's scenes where it's like you can tell they're expositioning something just to get some techno babble out and moving on. And then there's some scenes where there's like really powerful dialogue and reactions from the characters that, it's like, wow, this is really good. Like you can actually imagine them saying these things. But then sometimes it's like, well, why would anyone even say it? I don't know. It's just, and I think it's because I think the show just tries to keep the plot moving, that sometimes there's not enough time for like certain things to breathe. And so it just comes off as clunky. But I feel like the show's been that way since the very beginning. Like it was like, yeah, just gotta do what you gotta do. What I find interesting is just that because one of the creators was Ronald D. Moore, who was a writer on the next Star Trek Next Generation's middle of season 3 and then on, and then one of the showrunners for DS9, and then he was the creator and showrunner and writer for Battlestar Galactica. And so I like seeing the references to things that he has done over there, but also there's a lot of vintage Star Trek actors that show up in the show. So I'm always looking for that connection for some reason, because I'm weird. So yeah, I don't know. The one thing that the suspension of disbelief that I'm working through right now is just that they keep having the same handful of like important characters go back to Mars. And I'm just thinking, in a real life scenario, it's just like you would not have these same people going back on the same missions over and over. It's like, come on. I was actually thinking about it because I recently read through all of the space shuttle missions, which, there was like 120 of those. And it was pretty rare that I think only one astronaut might have done 4 shuttle missions or something. But it's pretty rare that it's like you go to space 2-3 times. And in this show, it's like, I don't know. And I mean, granted, it's got to be that way, because otherwise it's like it would just be new person every week. But it just kind of, I was just like, come on. There's got to be somebody else that can go to Mars. It doesn't have to be the same person every time. Okay. All right. So this wire, SD467. I wonder if that's an 8 or a B. Let's go do a quick search. All right, it's a B. Should the part numbers line up in what regard? Like, should they be the same? Yes. Am I going to put them in the exact same place as what the original schematic did? Not always. I generally try to start with where they're at, just because in general they put them in a certain place for a certain reason. But I don't try to keep that exact, because like this is a problem. But I'm not going to worry about this this wire going through the this text at the moment, just because like I can. Well, now that I pointed it out, I'm going to worry about it. There, we'll do it that way. But at the moment, I'm more worried about just getting the connections correct, and then the aesthetics can get fixed over time. Okay, so wow. This is supposed to connect to... we need one more resistor up here, don't we? Let's go ahead and put this in now. Oh, I have it. It's right there. Okay. I'm going to have to move stuff around to make this fit. R12. Thanks. Let me take a look. What are you saying? R12. R31. Okay. Yeah. Nope. Good call. Yeah, that I want to be the same. Yeah, the designators and the numbers, or the designators and the part numbers should be the same. Yeah, my bad. Thanks for pointing that out. I think I saw the D12 and I just got them confused. Okay. So I think what we're going to do, let me save this and let's do a quick commit in case I want to. All right, so that should be ignored. This can be ignored. I want to ignore everything beneath reference. All right. Stage all, and then this is moving T3. I'm not going to worry about exiting KiCad. It's pretty good about saving. I just want to do that because I want to. So let's go ahead and move this just down here. It's in here. I'm not going to worry about it. I'm going to move this up for the moment. Is what I'm trying to line up here is I want to get a left drag of these so that I can do a G and just move everything down. And for the moment, we're just going to come all the way down here. So then the next thing I want to do is take and we'll do a left drag of these. Nope, I changed my mind. I want to do a right drag, and then we're going to move that over. I am going to end up moving these, even though I said earlier I wasn't going to bother. Now I did. Nope, nope, nope. I want to do left drag. So left drag only selects the things that fit entirely inside the box. Right, wait, that was a right drag. Left drag selects anything that touches the box. So if I do a right drag, this wire doesn't get selected. But if I do a left drag of that same basic area, this wire gets selected because it touched the inside of the box, so it got selected. When you drag to the right, the component has to be entirely inside the box to be selected, which is why I wanted to do it this way. Anyway, to me that makes a lot more sense on PCB, but same functionality. All right, so then we can move this. We're just going to move that over to here. And then I can do same thing. I want to do the same way because I don't want it. I don't want to use. I'm using the G command to drag. See, get it? Drag for G. But what I don't want to do is I want that wire. I want it to automatically shrink. But if it's selected, then its endpoint just moves with everything else, and that ends up becoming a mess. So, okay. So I wanted to do all of that so that I could get to this point because we're trying to get, let's see, so this is almost lined up. I'm just going to draw another wire down here. I'm not in here. So I should be able to just like do this and go G, move that there. Because this goes R7, 68, 8.2, D1, and then R5 connects to here and to up here. So let's do this. Are we there? Oh, so close. There. All right. So that's connected. Looks like we're missing another wire up here. Okay, I think I see what's going on. And then this is the top side. It's the collector of this transistor. And this is going to come down here. All right. So I think that is the... Oh, what did you do that for? So I think this more or less matches up to about around here. I think there's a few things missing, but if we work backwards, so Q2, its base connects to the node that has R6 and L3. I can see it. It may not be as clear in the stream, but I can see that's where that line was. This is where the two pages were split. Which, by the way, is one of the reasons I liked redoing this is the bit. So this is part of the bit preserve project where we redraw the schematic, we redraw schematics in KiCad, because while this scan is pretty good, it was two separate pages that I had to stitch back together, and it's like it's just a pain to deal with. So anyway, moving on. 2 into 1, and that comes over here to Q1, and then that comes down here, which connects to this node, which is R5, which connects to that node, which skips this node, which was 4, goes back to the emitter, and then the base goes to pin 3, which goes through R7, 68, and that divides with R9 into the diode, and then we've got the capacitor. Oh, shucks. I screwed up. I forgot. I don't know if we're going to be able to fix this. Okay. So we need a little more space here. So I'm going to try and just drag this whole thing over using the arrow keys. There we go. Because there's supposed to be a wire coming from... This is not supposed to be connected. That was a mistake. Good thing we did the double check, because I did make that mistake. That connects down here. And that's between C26 and R3. Okay, and that comes down there, and then this can come back up here. All right, cool. Well, that actually worked out. I was a little bit nervous about making all those changes, but that seems like that worked. Consistent functionality is important, except for the change grid button, which should not work in Schematic. However, now that I've disabled that hotkey, I realized how much I needlessly changed the grid spacing in PCB. Like really, once you might want to have a coarse grid to position your parts, and then after that, it pretty much doesn't matter. So, and then, yeah, especially like when you get to silk screen and stuff. So it's like, anyway. Okay. So I want to see, okay, so I'm going to take a little bit of a break here because I want to see what this IC is. So let's see if we can find it. And then I think we're going to draw its symbol. We may not get to, yeah, I want to draw its symbol today. Okay. So what is a T18231? Well, I don't think it's a 3/4 inch square drive 40-inch long ratcheting wrench. So that's probably not what that part is. What if I just said an 18231? What's that come up with? I don't think, because these look like car parts. Yeah, no. I'm not entirely sure which Apple IIe power supply this is based on, but of the ones that I have, none of them have an alternator in them. So that's probably not it. I wonder if that's not an 8. What if it's like a T1B 231? No. What else could that be? What if it's a 6? I don't think... that's it. No. This says it's an IC regulator. What I find interesting is it connects to a 5-volt node somehow. Hey, this is that X mark again. I don't know what this is. I was thinking I was actually thinking it might be a transistor. But I'm not finding anything. Okay. I think at this point, I actually want to go look at a power supply and see if I can't figure out what that is, as among a couple other things that I'm not certain about. I'm just looking around at things. So the major work that we have left to do is this section, and then we got to make this transformer, since I'm sure there's not going to be one in KiCad already. And then fill out the rest of these, which isn't a big deal. Why is there an SCR on this side of the transformer? That's interesting. Anyway, and then I'm going to keep, I want to go, well, what I really want to do is I want to go look at one of my power supplies and see if I've got this IC in it. Because that's, I'm not sure what that is. I don't know what it's doing. The primary side. Huh. Okay. All right. I'm going to stop there. You guys know the drill. If you're not already in our Discord, you can come join there. I'm hoping, believe it or not, my current plan is by the end of January to have a new add-ons video out. Crazy idea, right? That's not the right URL. What the heck? Oh, but it works. Okay. Yeah, it works pretty good. So, all right. Well, thanks for hanging out. Thanks for hanging out tonight. I hope everybody has a safe new year. We'll be back next week. Probably be working on this. The only caveat is if the KiCad team does drop a release candidate for KiCad 8, then I'm going to switch. As soon as they do that, the next stream will switch to taking a look at that, because I would like to actually have a KiCad 8 tutorial introduction video ready to go around the time they introduce. So anyway, otherwise we'll be working on this power supply some more. I'm going to try and take a look at one. And in fact, what I will do next time is I'll have one up here so that we can actually look at it. Hopefully I've got the same one that they used. So we'll see how that goes. All right. Well, thanks for hanging out. It's good to see everybody. And as I said, have a happy new year. Take care.